polymorphism in C++. So poly means many forms, right? Multiple forms. In this we have studied lot of concepts. First let me discuss this. So generally there are two types of polymorphism: compile time and runtime polymorphism. In compile time we have function overloading and operator overloading, right? In runtime we have virtual functions, or you can say function overriding. Function overriding, right? So what is this polymorphism? Word polymorphism means having many forms. Poly, many forms, right? In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. Okay, so an example, if you see, a man at the same time can be a father, husband, or an employee. Three different roles. No, the best example is function overloading and operator overloading. Okay, so what we have studied in function overloading, you can have a same function name, right, with a different return type or different number of arguments or different data types of arguments if the number of arguments is same. That is function overloading. What is operator overloading? Giving a new meaning to the operators in programming. You can give meaning to this plus, you can give meaning to the multiplication. Right, we have also seen operator overloading concept. And in runtime overriding, in runtime we call this as function overriding. Okay, function overriding. How do we achieve that? We achieve it using virtual functions, right? So there are two types of polymorphism: compile time and runtime polymorphism. In compile time we have function overloading, operator overloading. Here we have virtual functions, right? So polymorphism is considered one of the most important features of object-oriented programming, right? So since we all studied this, again a revision of early binding and late binding. What is early binding and late binding? See, binding refers to the process of converting the variables into addresses. When does it happens? If it is having during compile time, it is called early binding. If it is being done during the runtime, it is called late binding. Okay, that's the difference between early binding and late binding. If the memory allocation for the variables is happening during the compile time, it is early binding. If that is happening during the runtime, it is called late binding. Can you tell me for DMA techniques, is the memory allocation happening, can be called as early binding or late binding? What can we call this DMA? Is it early binding or late binding? DMA techniques. When I am dynamically allocating memory, when is the memory allocated? During the compile time or the runtime? Right. So memory allocation is happening during it is called late binding, because during runtime only memory is allocated, not during the compile time. If you are using DMA techniques, memory is allocated during the runtime. So it can be considered as a late binding, right? So binding refers to the process of converting variables into addresses. Binding is done for each variable and functions, right? So this is an example. Again, same thing: runtime, compile time and runtime. Compile time and runtime, right? This is about binding, early binding and late binding. In same thing in polymorphism, we call compile time as early binding, runtime as late binding. Next, pure virtual functions and abstract classes in C++. What is this pure virtual function and abstract class? Right. So let's take an example. Let's see this example here. I will remove this virtual keyword, or this full thing, and I'll write void fun. Inside I have some cout statement like this. See, there is a base class. Try to understand this pure virtual function. Both are combined actually. Abstract classes which contain pure virtual functions are called abstract classes. Okay, so there is a base class, there is a private data member X, and in public I have a function void fun. Some set of statement is there inside it, and I have a derived class which is derived from this base class. Here also I have a function fun, right? So when I create an object for derived class, and when I write d.fun, which one is being executed? When I write d.fun, this is being executed. This is what our understanding is, right? We know that this will be executed because the derived class object will execute this, right? But how do I access the parent class function? How do I access the parent class function fun? One way you can write like this. You can write the base class, base, colon, then you can write fun like this. When you write like this, what will happen? The base class, or you can write d dot base colon fun. The object d dot base colon fun. With this, you can create or execute that function. The base class function can be executed, right? So, let's see this, right? Sometimes implementation of all functions cannot be provided in a base class, right? Because we don't know the implementation. See, in this void fun, this is a base class function. Base class has a function fun. Okay, let's not put this. There is a child class which is derived from the base class. It also has a function fun. Okay, sometimes we cannot write the implementation, the body of this function fun. Maybe that is same. Okay, maybe that is same. I want to write its definition. I want to write its definition or the steps to be executed under that function in the child class. I don't want to write in the parent class. I want to write its body inside child class. Okay, so how do I do that? See, we don't know. Such classes are called as abstract class. For classes where there are certain functions whose definition is not given or whose body is not given inside the base class. If its body is given inside the child class and it's only defined here, these kind of classes are called abstract classes. See, so we use a pure virtual function. In C++ is a virtual function for which we have an implementation, right? For which we have an implementation. So how do we define that? Syntax, you see, virtual, return type, function name, parameter list equal to 0. This way you have to do it. See, virtual void function equal to 0. If you write a function like this, this is called a pure virtual function. This is called a pure virtual function. And the class which contains a pure virtual function is called as abstract class. Why it is called abstract class? Because inside that abstract class there exists a function for which there is no definition or the body. There is no body of the function. Body is implemented in the child class. Okay, but why are you defining in the parent class? Maybe some other classes are using that. Some other child classes are accessing that. Okay, for that I may have to define the function there, right? So any class which contains a function whose body does not exist in the base class but exists in the child class, though such kind of functions are called as pure virtual functions, or such kind of class is called as abstract class, right? You definitely have to override the function in the derived class, otherwise the derived class will become an abstract class. Okay, what is the keyword virtual? Virtual indicates that the function can be overridden in the derived class. Next, equal to 0 makes the function pure virtual. Equal to 0 means there is nothing in that function. Generally we write equal to 0 to numbers only, but here we are writing to functions, meaning that function is a dummy function. It does not have anything. It is assigned a value 0, right? A class containing at least one pure virtual function is considered to be abstract class. See this syntax here. So data class, some class members, public, a pure virtual function. This is an example. See, we have a base class, I have a private data member, I wrote virtual void function equal to 0. And in the derived class, I have given the body of the function fun. Okay, when you do this way, then there is no confusion, there is no ambiguity, because compiler is easily able to access the child class function. I think we studied about ambiguity. Right? What is ambiguity here? This kind of ambiguities. What is the solution for that? We are using object dot a colon func. Right? So if there is some ambiguity here, we use the abstract classes. It is very clear now. Why? When you write d.fun, this is executed. Okay. Even if you write same program, let me create a object for base class b, and if I write b.fun, okay, b.fun, this will be called, because it is defined as virtual and it is given equal to 0. Means we are saying to the compiler that the implementation of this function fun is not provided in the base class, but it is given in the derived class. You can go there and execute it. Okay, whether you create a derived class object or a base class object, when you are calling a function b.fun, only the base class function is executed. Okay, so we are not giving any definition for the function fun in the base class. We are giving it only in the child class. Right? So this is your pure virtual function and abstract classes in C++. So this also comes under your polymorphism concept, because we are talking about virtual functions here. In that, one type of function is pure virtual function. Okay, if you are assigning a function fun in the base class, but not giving any definition or body to that function, not giving any body to that function in the class, but giving its body in the derived class, such kind of function is called pure virtual function, and such kind of a class is called as abstract class. Okay.